Hello, cosmic travelers. Welcome back to the channel. Today, we embark on a journey not just through space, but through time itself. We're going to count down 10 of the most mind-blowing astronomical discoveries made by our ancient ancestors. These aren't just quaint historical footnotes. They are profound testaments to the human mind's relentless drive to understand its place in the universe. Imagine for a moment a world without telescopes, without computers, without the vast body of scientific knowledge we take for granted. In that world, our ancestors looked up at the same sky we see today and saw not just a canopy of twinkling lights, but a grand cosmic clock, a map, a divine storybook. These ancient wonders, etched in stone, bronze, and bone, continue to puzzle and inspire us. How did they know? How did they achieve such astonishing precision with the tools they had? The answers are not always clear, and the mysteries they present are as deep as space itself. These discoveries remind us that science is not a modern invention, but a fundamental human impulse, an unbroken chain of curiosity stretching back to the dawn of our species. They challenge our assumptions about the past and deepen our appreciation for the long, arduous, and beautiful quest for knowledge. So, get comfortable. Suspend your disbelief and open your mind to the wonders of the past. Together, we'll explore the ingenuity of ancient astronomers and ponder the deep connection between humanity and the cosmos. This journey will take us from the windswept plains of England to the sun-scorched deserts of Egypt, from the jungles of Central America to the heart of ancient India. We are the inheritors of this cosmic legacy, and it's time to unwrap these incredible gifts from our past. Let's begin our countdown. Our journey begins in the heart of modern-day Germany, with a discovery that rewrote our understanding of Bronze Age Europe. Unearthed in 1999 by treasure hunters, the Nebra Sky Disk is a stunning object, a bronze plate about 30 centimeters in diameter, inlaid with gold symbols. At first glance, it's a beautiful piece of art. But look closer. That's not just random decoration. What you're seeing is a representation of the cosmos, the oldest concrete depiction of the night sky ever found. It's a snapshot of the universe as seen by people who lived 3,600 years ago. The symbols are unmistakable to an astronomer's eye. There's a full moon, a crescent moon, and a cluster of 7 stars we immediately recognize as the Pleiades. The remaining golden dots are scattered stars, and the golden arcs at the edges perfectly mark the angle between the sunset and sunrise points at the winter and summer solstices. This wasn't just a pretty picture, it was a functional astronomical instrument. It was a tool for understanding the rhythms of the heavens, and by extension the rhythms of life on Earth, governing the planting and harvesting of crops. But how was it used? Was it a farmer's almanac, a portable guide to the seasons? Or did it serve a deeper, more spiritual purpose? The Pleiades held significance in many ancient cultures, their appearance in the autumn sky signaling the time for harvest and mourning the dead. The disk might have been a ritual object, used by a priest or shaman to connect the earthly realm with the celestial one, a sacred calendar that harmonized human activity with the cosmic dance. The controversy surrounding the disk is as fascinating as the object itself. Its initial discovery by looters meant its archaeological context was lost, leading some to question its authenticity. But rigorous scientific analysis has confirmed its age and origin. The copper came from the Austrian Alps, the gold from Cornwall in England. This implies a vast network of trade and communication across Bronze Age Europe, a world far more connected and sophisticated than we previously imagined. So the Nebra Sky Disk remains an enigma. Is it a scientific instrument, a religious icon, or both? It represents a profound moment in human history when we first tried to capture the cosmos, to hold a piece of the sky in our hands. It's a tangible link to our ancestors' sense of wonder, a silent testament to their desire to find order and meaning in the vast, silent spectacle of the night. It tells us that the sky has always been our guide and our inspiration. From a portable map of the sky, we travel north to the Salisbury Plain in England, to an icon of the ancient world so famous it's almost a cliché. But don't let its familiarity fool you. Stonehenge is one of the most sophisticated and mysterious prehistoric observatories on the planet. Forget the myths of druids and Merlin. The true story of Stonehenge is far more impressive. Its construction began over 5,000 years ago, long before the Celts arrived in Britain, and it was built and rebuilt over a period of 1,500 years. Think about the sheer effort involved. The massive sarsen stones, some weighing over 40 tons, were dragged from 20 miles away. The smaller blue stones, weighing up to 4 tons each, came from the Preseli Hills in Wales, a staggering journey of over 150 miles. How did a Neolithic people, with no wheels and no metal tools, accomplish such a monumental feat of engineering? It's a question that still baffles archaeologists, a testament to the builders' incredible determination and social organization. But why did they build it? The answer is written in the stones themselves, in their precise alignment with the heavens. Stand in the center of the circle on the longest day of the year, the summer solstice, and you will see the sun rise directly over the heel stone, a solitary monolith standing just outside the main circle. Turn around on the shortest day, the winter solstice, and the setting sun will perfectly frame itself between the uprights of the tallest trilithon. This is no coincidence. Stonehenge was a celestial clock, a calendar in stone. It marked the turning of the seasons, the critical moments in the agricultural year that meant the difference between feast and famine. It was a place where the entire community could gather to witness and celebrate the predictable, comforting cycles of the cosmos. The sky for them was not a distant, abstract thing. It was an active participant in their lives, its movements directly tied to their survival and prosperity. But its secrets run deeper than just the sun. More recent research suggests that Stonehenge may have also been used to track the far more complex cycles of the moon, perhaps even to predict lunar eclipses. Imagine the power this would have given its keepers. The ability to foretell when the moon would be devoured by a shadow, a terrifying event for ancient peoples. Stonehenge was not just a temple. It was a center of knowledge, a place of power, a silent, stony testament to a people who sought to understand and predict the rhythms of the universe. We now leap forward in time and across the globe to 18th century Jaipur, India. Here we find something utterly unique, Jantar Mantar. This is not a circle of rough-hewn stones, but a collection of 13 colossal architectural instruments. An observatory that looks more like a surrealist sculpture park than a scientific facility. Built by the Rajput king Sawai Jai Singh II, it represents a magnificent fusion of science, art and religion, a high point of naked-eye astronomy. Jai Singh was not just a king, he was a scholar and a passionate astronomer. Dissatisfied with the existing astronomical tables of his time, which were full of inaccuracies, he decided to build his own instruments to create a more precise catalogue of the heavens. But instead of small, portable brass instruments, he thought big. He reasoned that the larger the instrument, the more accurate its measurements would be, and so he built these giants out of stone and marble. Look at the Samrat Yantra, the supreme instrument. It's a massive sundial, 27 meters high. Its shadow moves at a discernible pace, about the width of a human hand every minute, allowing time to be measured with an accuracy of just 2 seconds. Then there's the Jai Prakash Yantra, a pair of hemispherical bowls sunk into the ground that act as a map of the celestial sphere, allowing an observer to track the position of any star or planet as it moves across the sky. Each structure at Jantar Mantar is a marvel of mathematical and engineering genius. They were designed to measure time, predict eclipses, track the location of major stars as the Earth orbits the Sun, and determine the exact declinations of the planets. It was a place where the cosmos was made tangible, where the abstract movements of celestial bodies could be seen and measured on a human scale. The observer literally walks inside the instruments, becoming part of the measurement process. What makes Jantar Mantar so profound is that it wasn't just a secular scientific project. For Jai Singh, astronomy was inextricably linked with astrology and spirituality. Understanding the precise movements of the heavens was a way to understand the divine order of the universe. The observatory was both a laboratory and a temple, a place where mathematical precision met cosmic reverence. It stands today as a vibrant monument to a time when science and spirituality were not seen as opposing forces, but as two sides of the same quest for truth. Let's journey to the dense jungles of Mesoamerica, to the civilization of the Maya. For many, the Mayan calendar is synonymous with the 2012 Doomsday Prophecy, a sensationalist misunderstanding of a system far more complex and beautiful. The Maya were not predicting the end of the world. They were masters of time, and their calendrical systems were among the most sophisticated ever developed in the ancient world. They didn't have just one calendar. They had a whole interlocking system of them. First, there was the Harb, a 365-day solar calendar much like our own, used for agriculture and tracking the seasons. Alongside it ran the Tzolk'in, a 260-day sacred calendar used for divination and scheduling religious ceremonies. These two calendars ran in parallel, like two interlocking gears. The date on which a specific day in the Harb and a specific day in the Tzolk'in coincided would not repeat for 52 years. This 52-year cycle, known as the calendar round, was a major unit of time for the Maya, marking the lifespan of a person. But they went even further. For tracking history over vast stretches of time, they used the long count. This is the calendar that famously ended in 2012. But it wasn't an end. It was simply the completion of a major cycle, a Baktun, much like our calendar rolls over from December 31st to January 1st. For the Maya, time was cyclical, not linear. The end of one great cycle was simply the beginning of another, a time for cosmic renewal and celebration, not destruction. Their astronomical knowledge was, honestly, just breathtaking. From observatories like the one at Chichen Itza, their priest astronomers meticulously recorded the movements of the sun, the moon, and the planets, especially Venus. They created tables to predict solar and lunar eclipses with stunning accuracy. They understood the synodic period of Venus, the 584 days it takes to reappear in the same spot in the sky, and wove this cycle into their mythology and architecture. The very steps and platforms of their pyramids often correspond to calendrical numbers. The Mayan worldview was one where time, astronomy, and religion were a single unified fabric. The movements of the celestial bodies were the actions of the gods. To track the heavens was to understand the divine will. Their pyramids were not just tombs or temples. They were sacred mountains built to align with the cosmos, stages for rituals that synchronized human life with the grand, repeating cycles of eternity. Their legacy is a reminder that for some cultures, timekeeping was not a mere convenience, but the highest form of sacred science. We return to North America to a remote canyon in the high desert of New Mexico. Between 850 and 1250 AD, Chaco Canyon was the center of a thriving culture, the ancestral Puebloans. They built massive multi-story stone structures, great houses, with hundreds of rooms, all without pack animals, the wheel, or metal tools. For decades, the purpose of this vast complex was a mystery. But hidden throughout the canyon are clues that reveal its true purpose. It was a ceremonial center meticulously designed to mirror the cosmos. The most famous discovery here is the Sun Dagger. High on a cliff face, behind three massive sandstone slabs, are two spiral petroglyphs carved into the rock. For most of the year, they remain in shadow. But on the summer solstice, at midday, a single sliver of light, a dagger, pierces the darkness and perfectly bisects the larger spiral. At the winter solstice, two daggers of light appear and precisely bracket the same spiral. And at the equinoxes, the larger spiral is struck by one dagger, while the smaller spiral is bisected by another. It's an ingenious and subtle solar marker, a celestial calendar that required a sophisticated understanding of the sun's annual journey. But the sun was not their only focus. The architecture of the great houses themselves reveals an even deeper astronomical knowledge. The major buildings are aligned not just with the cardinal directions, but also with the solar and lunar cycles. For example, the north wall of several buildings, hundreds of meters long, is aligned with astonishing precision to true north. Even more remarkably, the Chacoans seem to have tracked the 18.6-year lunar standstill cycle. This is the wobble in the moon's orbit, causing its rising and setting positions on the horizon to swing between northern and southern extremes over nearly 2 decades. The placement and orientation of many Chacoan roads and buildings align perfectly with these extreme positions of the moonrise and moonset. This is a subtle, long-term cycle that is very difficult to observe without decades of patient, dedicated record-keeping. Chaco Canyon was a sacred landscape, an architectural model of the Puebloan cosmos. The buildings were not just dwellings. They were observatories and ceremonial spaces designed to harmonize the human world with the rhythms of the sun, moon, and stars. It was a place where the sky was brought down to earth, where architecture became a living calendar. The people of Chaco created a civilization that was not just in a place but was of a place defined by the sky above. Our cosmic journey now takes us to the Fertile Crescent, to ancient Mesopotamia, the land between the rivers Tigris and Euphrates. Here, more than 3,000 years ago, the Babylonians practiced a form of astronomy so systematic and mathematical that it laid the foundations for everything that followed. Working in a world of clay tablets and cuneiform script, their priest-scribes created a legacy of celestial observation that would influence Greek and Islamic astronomy, and through them, the entire Western scientific tradition. They were meticulous record keepers. For centuries, they compiled detailed astronomical diaries, noting the position of the moon and planets, the times of solstices and equinoxes, and most famously, the occurrence of eclipses. They weren't just passively observing, they were looking for patterns, for predictability in the heavens. They were the first to recognize that astronomical phenomena are cyclical and can be predicted using mathematics. One of their greatest achievements was the creation of the zodiac. They divided the ecliptic, the sun's annual path across the sky, into 12 equal segments, each named for a constellation. This wasn't just for astrology, it was a convenient coordinate system, a way to map and measure the positions of the planets, sun and moon. When a Babylonian scribe recorded that Jupiter was in the head of the lion, it was a precise astronomical statement. Using arithmetic methods, they developed sophisticated algorithms to predict the future positions of celestial bodies. They could calculate the time between new moons, the variable speed of the sun across the sky, and the complex movements of the planets. They discovered the Saros cycle, a period of approximately 18 years, 11 days, and 8 hours, which they used to predict lunar and solar eclipses with remarkable success. This was not just qualitative observation. This was quantitative, mathematical science. For the Babylonians, astronomy and astrology were one and the same. The movements of the planets were not just geometry. They were omens from the gods. A lunar eclipse might foretell the death of a king. The position of Mars might signal war or famine. Their quest to understand the heavens was driven by a deep-seated need to understand their fate. And in their attempt to read the future in the stars, they inadvertently invented the mathematical tools that would allow future generations to understand the true nature of the cosmos. In the year 1900, sponge divers working off the coast of the Greek island of Antikythera discovered an ancient Roman shipwreck. Among the statues and pottery they brought up was a corroded lump of bronze, which for decades sat largely ignored in the National Archaeological Museum in Athens. It wasn't until the development of advanced X-ray and CT scanning technology in the late 20th century that the true nature of this object was revealed. What they found was honestly simply astonishing. Hidden inside that lump of corroded metal was a complex system of at least 30 interlocking bronze gears. This was the Antikythera mechanism, and it was nothing less than an ancient analog computer. Dated to the 2nd century BC, it is by far the most technologically sophisticated artifact ever found from the ancient world. Nothing approaching its complexity would appear again for over 1,000 years, until the astronomical clocks of medieval Europe. So what did this incredible device do? It was a mechanical model of the cosmos. By turning a hand crank, the user could set it to any date, past or future. The front dial would then display the position of the sun and the moon against the zodiac, as well as the phase of the moon. It was an intricate calendar, tracking not just the days, but also the 4-year cycle of the Pan-Hellenic Games, including the Olympics. It was a social and religious organizer, but the back dials revealed its true genius. They were designed to predict eclipses. The mechanism modeled the Saros cycle, which the Greeks had learned from the Babylonians, but it went even further. The ancient Greeks knew that the moon's orbit is not a perfect circle. It's actually an ellipse, meaning the moon sometimes moves faster and sometimes slower. The designer of the mechanism brilliantly accounted for this anomaly, using a pin and slot system of gears, which is just a breathtaking feat of mechanical engineering. The Antikythera mechanism shatters our preconceptions about the technological capabilities of the ancient world. It demonstrates that at least some Greek engineers had achieved a level of mechanical and mathematical sophistication that we previously thought impossible. Who built it? Perhaps the great astronomer Hipparchus, or maybe even Archimedes himself. We may never know. It stands as a solitary miracle, a ghost of a lost technological tradition, a testament to a forgotten lineage of genius that could model the heavens in bronze. We travel back in time, deep into the Neolithic period, some 7,000 years ago. In what is now Germany, near the town of Goseck, aerial surveys in the 1990s revealed strange circular patterns in a wheat field. Excavation uncovered something remarkable: the remains of the oldest known solar observatory in Europe, predating Stonehenge by more than 2,000 years. It's known as the Goseck Circle. What the archaeologists found were the outlines of 2 concentric circular ditches and 2 concentric palisade fences, about 75 meters in diameter. The fences would have been made of massive wooden posts, creating an enclosed sacred space. This wasn't a settlement or a defensive structure. It had 3 gates set at specific points in the palisade walls. The purpose of these gates becomes clear when you consider the sky. Looking from the center of the circle, the southeastern gate aligns perfectly with the point of sunrise on the winter solstice, the shortest day of the year. The southwestern gate aligns just as perfectly with the winter solstice sunset. The northern gate has no obvious astronomical alignment, and its purpose remains a mystery. Perhaps it was simply an entrance. This was a place built to capture the sun at its weakest, to mark the turning point of the year when the days would begin to grow longer again. For these early Neolithic farmers, this was a moment of immense importance. The winter solstice marked the death and rebirth of the year. It was a time of anxiety, but also of hope. To be able to predict and mark this moment was to have a degree of control, to know that the light and warmth would return. The Goseck Circle was a place for the community to gather, to perform rituals, and to reaffirm their connection to the life-giving cycles of the sun. The discovery of the Goseck Circle and other similar earthworks across Europe has forced us to reconsider the sophistication of these so-called primitive societies. These were people who, just a few generations removed from a hunter-gatherer lifestyle, were already making precise, long-term observations of the sky. They were applying this knowledge to create large-scale public works that encoded their understanding of the cosmos. The Goseck Circle is a silent, earthen monument to the very beginnings of systematic astronomy in Europe. Our quest now takes us to ancient China, during the Shang dynasty, more than 3,000 years ago. Here, the origins of astronomy are found not in stone or metal, but in bone. The oracle bones are pieces of ox scapula and turtle plastron, the flat underside of the shell, which were used for a form of divination called pyromancy. A question would be inscribed on the bone, a hot poker would be applied, and the resulting cracks would be interpreted as answers from the ancestors or deities. Thousands of these bones have been unearthed, and they provide an incredible window into the concerns of the Shang kings. Questions about harvests, warfare, childbirth, and illness. But among these earthly concerns are records of celestial events. The Shang diviners were also the court astronomers, and they meticulously recorded what they saw in the sky. Their primary interest was in transient, unpredictable phenomena, which were seen as potent omens. Inscribed on these ancient bones are the earliest known records of solar and lunar eclipses in any civilization. One famous inscription reads, "On day Guiyu it was divined. The sun was eclipsed in the evening, is it good?" Another says, "The 7th day of the month, a GC day, a crescent moon. There was a great new star that appeared in the company of Antares." This could be the first recorded observation of a supernova. These records mark the beginning of one of the world's longest and most continuous astronomical traditions. The data collected by the Shang astronomers and their successors through subsequent dynasties would create a repository of celestial observations spanning millennia. This long baseline of data allowed later Chinese astronomers to make remarkable discoveries, including the cyclical nature of sunspots and the precession of the equinoxes. The oracle bones show us an astronomy born from a desire to communicate with the supernatural, to interpret the will of the heavens. For the Shang, a comet wasn't a ball of ice and dust, it was a broom star sweeping away the old to make way for the new. An eclipse wasn't a predictable alignment of celestial bodies, it was a dragon devouring the sun. Yet within this mythological framework, they practiced careful, empirical observation, laying the groundwork for a rich scientific legacy that would flourish for thousands of years. For our final and most ancient wonder, we travel to a place you might least expect to find a major astronomical observatory, the desolate, hyper-arid landscape of the Egyptian Sahara, a region now part of the vast Nubian desert. Here, at a site called Nabta Playa, lies what may be the oldest astronomical site in the world. Long before the pharaohs built the pyramids, nomadic cattle herders erected a series of standing stones that mark a profound connection to the cosmos. Dating back an astonishing 7,000 years, and possibly even earlier, Nabta Playa is home to a small stone circle, radial lines of megaliths and other structures. For years, the arrangement of these stones seemed random, the work of a forgotten people in a now inhospitable land. But a closer look, combining archaeology and astronomy, revealed a stunning cosmic purpose. The stones are not random at all. They are a prehistoric calendar. The main stone circle, though small, contains key alignments. A pair of stones frames the rising sun on the summer solstice, the most important day of the year for a people dependent on seasonal rains. Imagine, in this harsh desert environment, the arrival of the summer monsoon was a matter of life and death. This stone circle was a tool to predict its onset, a celestial signal that the life-giving rains were coming. But the alignments go beyond the sun. Another set of stones seems to align with the rising point of the bright star Sirius, which, due to the precession of the equinoxes, also heralded the summer solstice at that time. Even more remarkably, a set of larger stones, located about a mile from the circle, seems to replicate the orientation of the three stars in Orion's belt. This Orion correlation predates the more famous theory about the Giza pyramids by thousands of years. Nabta Playa forces us to rethink the very origins of civilization and science. It suggests that the drive to create calendars, to track the stars, and to build monumental structures aligned with the cosmos did not begin with settled agricultural societies. It may have begun with nomadic peoples who carried a sophisticated understanding of the sky with them as they moved across the landscape. In the silence of the Sahara, our distant ancestors laid down the first stones of humanity's long and enduring quest to find its place among the stars. From the sun-scorched stones of the Sahara to the intricate bronze gears of ancient Greece, we've seen that our ancestors were not so different from us. They were driven by the same fundamental curiosity, the same desire to find patterns in the chaos, the same need to feel connected to something larger than themselves. They looked to the skies for answers, for guidance, for a sense of order in a world that was often unpredictable and dangerous. The sun, the moon, and the stars were their clock, their calendar, and their map. The cosmos was not a subject to be studied, it was a living presence, woven into the very fabric of their existence. Today, we look at the sky with powerful telescopes that can see to the edge of the observable universe. We have equations that describe the birth of stars and the death of galaxies. But does that mean we've lost the sense of wonder that our ancestors felt? I don't think so. Every new discovery, every new image from the James Webb Space Telescope only deepens the mystery. The universe is, and has always been, the greatest source of awe and inspiration for the human spirit. The quest that began at Nabta Playa continues today, in every laboratory and observatory on Earth. So, the next time you find yourself under a clear, dark sky, take a moment. Look up. Remember the millennia of human eyes that have gazed upon that same vista. Think of the minds that built Stonehenge and the hands that carved the Nebra Sky Disk. You are part of that unbroken chain of cosmic curiosity. If you want to continue exploring these timeless mysteries with us, be sure to subscribe and join our community of fellow travelers. Keep looking up.